welcome to a little video about modeling linear inequalities. All right. So number 1 and 2, all that we are going to do is create the inequalities. We're not going to solve them, we're just going to write them. Okay. Number 1. Adrian saved $200. He already spent $25. He plans to spend $5 on Starbucks drinks each week. Write an inequality to represent the number of Starbucks drinks he can buy. All right. So let's see what he begins with. It looks like Adrian begins with $200. So I'm going to go ahead and write that down. 200. Now, ask yourself, can he spend more or less than the $200 he has? Well, he can only spend less because he can't spend more money that he doesn't have. So we need to make sure that we spend less than $200. Now, if Adrian felt like it, could he spend all $200? Yeah, why not? So I'm going to put an or equal sign down there. So whatever he spends has to be less than or equal to $200. Okay. So he already spent $25. So I'm going to go ahead and write 25. That's unchanged. I can't do anything about that 25. It's been spent. He plans to spend $5 on Starbucks each week. So he plans to spend $5 on Starbucks each week. So let's do $5 a week. And that's it. So he's already spent $25, and the money that he's going to spend must add up to be less than or equal to $200. Onwards we go. Whoops. Okay. Vivian wants to buy a ton of Air Jordans. She worked all summer and saved $650. She already spent $145. She plans to spend $150 on a pair of Air Jordans per month. Write an inequality that represents the number of Air Jordans she can buy. Okay, so first, how much did she save? Well, it looks like she saved $650. Let's write that down. Now, of the money she saved, can she spend more than that? No, she has to spend less than that. Can she spend exactly $650? Sure. That's why we'll give an or equals to under that inequality symbol. Okay. Now, she already spent $145. So that $145 is gone. It's not going anywhere. So I'm just writing $145 without any variables. She plans to spend $150 on Air Jordans per month. So and is plus. She's going to spend $150 per month. So whatever she spends, however many months she's able to buy Air Jordans, plus the $145 she already spent, has to add up to less than $650 because she cannot spend money that she does not have. Okay. Now, the next thing we're going to do is solve and graph inequalities. And the only difference between solving inequalities and solving equations is that if we multiply or divide both sides of an inequality by a negative number, we need to reverse the symbol. So we need to flip it. Okay, so let's take a look at number 3. I don't know if you can hear that. An ambulance is driving past my classroom. That is loud. Okay, now I can concentrate again. Hello, I'm back. Number 3 has 3 over 2x is greater than or equal to 4. You know what? I'm going to rewrite it on the side because I don't think I have room to do it here. 3 over 2x is greater than 4. Okay. In order to get rid of fractions, what we must do is we multiply both sides by the reciprocal, which means we flip the fraction. So on the left side, the 2's and 3's cancel. We're left with x. Since we multiplied by a positive number, our sign stays the same. 4 times 2/3 is 8/3. And 8/3 is 2.7-ish. So x is greater than 2.7. When we have a symbol that looks like this, like a greater than or a less than, I want to remind you that we do an open circle to graph that. I'm going to move that right here. When we have a symbol that's greater than or equal to or less than equal to, we graph it with a colored in dot. So, number 3 has x is greater than 2.7. So let's find 2.7. It's somewhere right here, and we're going to make a little open circle. Greater than. I want to draw an arrow pointing to the correct direction. Would greater than be to the right or to the left? Well, if we take a look at our number line, the numbers get bigger to the right and smaller to the left. That means we're going to draw an arrow to the right. Number 4, ooh, fun, another fraction. I'm going to go ahead and rewrite it. Oh, and it's a less than or equal to, so that means we're going to have a colored in dot here. Okay, so negative 2/3 x is less than or equal to 4. In order to solve that, we're going to multiply both sides by negative 2/3. There we go. On the left. No, we're not multiplying by 2/3. Oh my goodness, we're multiplying by 3/2. Silly GUmin. Silly GUmin. Okay. Let's try that again. On the left, the 2's, the 3's, and the negative cancel. All we're left with is an x. Now I am multiplying both sides by negative 3/2, so my symbol flips. Check it out. It faced this way. Now it's that way. All right. 4 times negative 3 is negative 12, divided by 2 is negative 6. All right. So on my number line, I'm going to find negative 6. There it is. I'm going to put a little dot on it. It's going to be a closed dot this time because it's greater than or equal to. Because it's greater than, we're going to point an arrow to the right. A little hint, the way I remember how to do this is less is left. So that kind of works. Okay, number 5. Okay, I don't need to rewrite this one, but I will zoom in. Okay, so we have 78 minus x on the right side. So what I'm going to do to get x by itself, I'll start with subtracting 78 from both sides. Okay. On the left side, 80 minus 78 is 2. My symbol stays the same. All I did was subtract. 78's cancel, and I'm left with negative x. Now question, what number is actually in front of the x? Well, if we take a close look at it, the number that's in front of the x is actually negative 1. It's just an invisible 1. Like that. So, in order to get rid of the negative 1 that's next to x, we're going to divide both sides by negative 1. Because negative 1x is negative 1 times x. Okay. On the right side, they cancel because that was the point. On the left side, 2 divided by negative 1 is negative 2, and the symbol in the middle flips because I divided by a negative number. Now, this looks a little weird because the x is on the other side, but that's okay. It's okay that it is. If you want to, you can always rewrite it, but you gotta make sure it looks the same. The symbol is facing the same way. All right, so the pointy end is towards x. So x is less than or equal to negative 2. Let's check it out. All right, so negative 2 gets a dot. Oh no. Oh no. Oh no, where did it go? Oh, okay, phew. So negative 2 gets a closed circle. Oh no, it did it again. Uh-oh. What is happening? It's fine, I'll erase that later. All right, I'll gently give negative 2 a closed circle. And then because x is less than negative 2, we're going to point the arrow to the left. Less is left. Right. Number 6. 10 is less than 7 minus 2x. All right. To start off, I'm going to subtract 7 from both sides. Okay. 10 minus 7 is 3. The 7's on the right cancel, and we're left with negative 2x. In order to get rid of the negative 2 that's next to x, we are going to divide both sides by negative 2. Okay. They cancel here. Beautiful. On the left, 3 divided by negative 2 is negative 1.5. X on the right. And because we divided by a negative, our symbol must flip. So x is actually less than 1.5, negative 1.5. All right, let's find negative 1.5 on our number line. That's right here. We're going to make an open circle on it. And because it's less, our arrow goes to the left. Number 7. I'm going to start this off by subtracting 5 from both sides. On the left, 18 minus 5 is 13. My symbol stays the same because all I did was subtract. And I'm left with 3x on the right. In order to get rid of the 3 that's next to the x, we're going to divide both sides by 3 because 3x is 3 times x. And we undo multiplication with division. All right. 13 divided by 3 is 4.3. Our symbol stays the same because we did not divide by a negative. And then we have x. So x is greater than 4.3. Let's graph it. All right. 4.3 is somewhere like, whoops. What's happening? Right over here-ish. Uh-oh. Don't be mean. Okay, perfect. Since x is greater than that, we're going to draw an arrow going to the right. Oh, it's a tiny arrow, but that still works. It's still going to the right. All right. Number 8. Greg's camping group hikes down their campsite. The function represents Greg's elevation over 240 minutes. Erin's campsite has an elevation of 3,000 feet. She'll meet up with Greg's group to hike all the way down the remainder of the mountain together. Let's graph the linear equality to represent where Erin will hike. Okay, so here is our graph. Now, Erin is meeting us, or I guess Greg is meeting Greg at 3,000 feet. So 3,000 feet happens right there. Let's see where 3,000 hits our graph. Boop, ba-doop, ba-doop. Right there. Right there. There we go. It is not responding well today. I'm sorry, folks. All right, so that's where they meet. And then they travel down together. So let's just trace that like that. And that's where they go down together. Number 9. The junior class club is selling boxes of popcorn in order to raise money to go to the field trip. The function represents, the total sales for 600 boxes sold. The club will only have enough money if their sales reach 1,600 or greater. Let's graph the linear inequality to represent when the club will be able to go on the field trip. Okay, so we're looking for 1,600. So let's find 1,600. There it is. Let's see where it hits our graph. Boop, 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 boop. Here. So this is where it meets the graph. And we could sell more than $1,600, 1,600 or greater. So let's trace our graph going up. All right. So it kind of looks like we need to sell 420 boxes or more in order to achieve these junior class field trip. Okay. If you have any questions about today's lesson, please let me know. Otherwise, have a wonderful rest of whatever day it is for you. Bye!